Electrical machinery 1 with explanation to my question answer used for TNEB and TNPSC and semester exam. First question. Torque developed in a DC motor depends on A. Choices. Active length of the conductors and number of armature conductors. B. Magnetic field and radius of armature. C. Current flowing through the armature conductors. D. All of the above. Answer is all of the above. Torque developed in a DC motor depends on active length of conductors and number of armature conductors, magnetic field and radius of armature, current flowing through the armature conductors. All of the above. Answer. Reason. T cross is equal to T armature is equal to 0.0162 pi is into IA divided by A into P in kg meter. TA is 0.159 pi is at IA divided by A into P in Newton meter. T shaft is equal to TA minus T loss. Torque T is force into R. Radius, R is radius. F into R, that is F is force, R is radius. Torque is F into R and Newton meter. That is acted upon by a circumferential force of F Newton. Second question. The horsepower obtained from the motor shaft is called. Answer is BHP. Choices A. BHP shaft of useful torque, none of the above. That is answer is BHP. BHP is brake horsepower. Shaft of TSH, the torque which is available for doing useful work is known as shaft torque. The horsepower obtained by using the shaft torque is called brake horsepower. BHP because it is the horsepower available at the brake. The efficiency of a DC motor when developing maximum power will be about, that is less than 50% motor efficiency. Speed regulation. Reason for efficiency less than 50%. Speed regulation. The speed regulation is defined as the change in the speed when the load on the motor is reduced from rated value to 0 as percentage of the rated load speed. Percentage speed regulation is equal to no load speed minus full load speed divided by full load speed into 100. That is dN divided by N into 100. Reason. Take formula percentage of speed regulation is no load speed minus full load speed divided by full load speed into 100. Put A answer in that formula. 825 minus 75 divided by 75, 750 divided by 75 into is equal to 750 divided by 75 is equal to 10. Get 10% answer. The direction of rotation of a DC compound motor can be reversed by interchanging the position of armature. Answer is A. Armature. Reason. Armature reaction in a DC motor we learn when armature conductors are carrying current. MNA is shifted by angle theta in a direction opposite to the direction of rotation of armature. Fifth question. A DC shunt motor is running at light load. What happens if the field winding gets open? Answer is motor will pick up high speed. Reason. Mechanical characteristics. Speed is high, torque is low and vice versa. That is N divided by T. Characteristics. N proportional to EB divided by pi. Change in EB varies. IA is small. IA is low. IA decreases, N increases. That is N is speed, IA armature current. Torque TA armature torque proportional to IA square. Sixth question. In an electric motor, the electromagnetic torque developed. Answer is in opposite direction to both load torque and fractional torque. That is A answer. Reason. The electromagnetic torque developed in an electric motor is commonly called developed torque or induced torque. It represents the torque generated from the conversion of electrical power into mechanical power due to the interaction of the motor's magnetic fields and the electric currents. within the conductors. The electromagnetic torque is the same as the direction of rotation. Positive power flow from the electrical system to the mechanical output. In an electric motor, the electromagnetic torque developed is in the opposite direction to the load torque and the frictional torque. This opposing torque is what enables the motor to drive the load and overcome friction for the motor to rotate. The developed torque must overcome the opposing torques from the load and friction, resulting in a net accelerating torque. Seventh question. In a DC motor, the shaft torque is less than armature torque. This is due to answer C. Stray laws. Reason. The difference between a DC motor's armature torque and its shaft torque is due to iron losses and mechanical losses. That is friction and windage. Iron losses plus mechanical losses is called stray loss. A portion of the total electromagnetic torque developed in the armature is consumed by these losses, reducing the amount of torque available at the motor shaft for doing useful mechanical work. Seventh question. The starting torque of a DC shunt motor is answer is low. The circuit diagram of DC shunt motor is shown in figure. That is armature current IA, armature winding A1, A2. Almost constant at start, and the formula for torque is T proportional pi into IA, flux times the armature current. DC series motor high starting torque, that is very important one. DC shunt motor says the shunt field flux remains nearly. Shunt field winding is connected parallel to armature of motor, that is plus minus supply, DC supply. DC shunt motor circuit. The starting torque of a DC shunt motor is low. Starting torque because it is flux is almost constant at start. Constant from the start, and the armature current is limited to prevent damage. The resulting starting torque is comparatively small, making it less suitable for loads requiring high initial twisting force.